Namaskar my dear friends. So as we had seen the diode circuit, so what we'll do is we have this particular diode circuit, this one, and we are going to see the voltage drop across this diode is actually less than 0.7. That's the reason diode is not working. Diode is in off condition. So our aim is to make this diode on. It means the voltage drop across this R2 should be more than 0.7 volt, right? So in that case what we can do is let us increase the like input voltage to, let's say, 5 volt. So if this is 5 volt, then we can rerun it and see what is the state. So the state of this particular diode is going to be 0.7. So why it is happening? Let me just delete this. Sorry. Let me just delete this diode. Okay. Now we will see what is the voltage across output. So if you see here, this is my input voltage, which is 5 volt. Sorry. This became 2 again. Okay, so the voltage across this particular input is 5 volt and voltage at this output is how much? Close to 3.9 volt, right? Or you can have a cursor here, put left click, so you can have a cursor, and this cursor is showing you the value almost how much? 3.75 volt, right? Now once we put the diode, let us say I'll put diode, what is going to happen? This delete one. Yes, so this is my diode that is put now. Now I'll run it. So what is going to happen is the voltage drop across this diode will be just 0.7, and this is how the circuit will not take path of resistor, it will take the path of diode, right? So just let's rerun it again. I will okay, this is my 5 volt and this 5 volt is there, this is diode. So diode is going to give me the value how much? Yeah, see, the output voltage is actually 4.38 volt or 4.35 volt. So the drop across this V input to V output is just 0.7 volt, you can see, because the voltage drop across R2 was that time 3.75 volt, but since there is a diode is making sure the path taken like this. So if you want, you can see the current through diode will be little bit higher. So it is around how much it is? At this place it is around 400 micro amperes, right? So this is how it is little bit increased. Or you can see the current across R2 will be little lesser, which is just 3.316 microamperes. If you see current across this is going to be in microamperes. So this is how you make sure the other path of the diode is working. Let's take another circuit. What we can do is, now your aim is to tell me what is the output voltage or which diode is on and which diode is off. Okay, so let's take one diode here, one more diode, I can keep it here, and we can take two resistors, one resistor across this, and let's say one resistor I'll keep it here, and one voltage source I'll keep, which will be, let us say this, and let's say this is my ground. Okay, wire it up. So there are a lot of diode based circuit, and like you can always enjoy this particular diode based circuit in simulation, and you will understand, instead of analyzing through manual calculation, you can always come here and try to simulate it and see how does the circuit behave, right? So let us say this voltage is 10 volt, we have two diodes in this fashion. Let us say this resistor is 2 kilo ohm and we have this resistor as, let's say, 8.3 kilo ohm. I am considering that diode drop will be around 0.7 volt, that's the reason I have taken this much. Okay, so the calculation is like that. Now my aim is to understand which one is on and which one is off, and the current across this diode D1 is how much. Okay, that's the question. Okay, the current across this diode is how much, that's the main question. So let's run it. So I'll run it for, let us say, 10 millisecond and start saving data from beginning, that is 0. So this is my circuit, and you can see my input voltage is 10 volt, my output voltage is how much? around 9.35 volt, right? If you want, you can have a cursor, and this cursor is showing me the value of 3.95 volt. Okay, because this diode is actually working, and this is how that much drop is there. Now if you want to see what is the current across this resistor, so this resistor current is around 1 milliamperes. This resistor current is around how much? 323 microamperes. Okay, so why it is happening? Because most of the current is actually flowing through this particular diode D1. Okay, and as you can see, the voltage drop between these two diode will be around 0.7. So let me just show it to you. Click here and then keep it, and then keep this one. So you can see voltage node 1 minus node 2, the difference is coming this bluish color, which is around 0.7 volt, right? Around 670 volt, that is 0.7 volt. Understood? The voltage drop between this and this, if you want to see, just click there and then hold it and keep it here. So you are going to see voltage between node 2 and node 3, which is red color. Node 2 is this one and node 3 is this one. So red color, that is going to give you again 647 millivolts. So both the diodes are in on condition, and that's how it is giving you this much voltage. Okay, so good. Thank you so much. You can always enjoy with like different diode circuits, and if you do have any questions regarding the simulation with diode circuitry and how to put this, then you can always do those jobs. Okay, now one more thing before closing this session, one more thing I'll just quickly tell you is, if you put it on like diode and then right click it, you have an option of pick new diode. Okay, so you can choose a actual diode in the like situation. So let us say I am going to put 1N4148. Okay, so 1N4148 is 75 volt diode with 200 milliamperes current rating. Okay, so this one I can put, and this is the diode name now. So this is the practical diode, or this is the diode which is available in industry. Same way you can pick this diode as well. If you want, you can pick another diode also, not a problem. But let us say I am going to put a Schottky diode for this. So this will be my Schottky diode, this will be my normal diode. So as you can see, for Schottky diode the voltage drop will be 0.3, and for normal diode voltage drop will be 0.7. So I'll just show it to you how it is working. Okay, so this is my input voltage 10 volt. Now let me just see what is the drop across this diode. So the drop across this diode is close to 0.8 volt. Okay, so you can see the diode drop across this is how much? It is 656 volt. Okay, so it is 656 volt. It was not able to show, so cursor 1 is at 656 volt. Now let us say voltage drop across this diode D1 is how much? So I'll just put cursor here, one more and then one more. So we are going to get voltage drop across node 2 and node 3. So that is in blue color. So that is again that much volt. Okay, so this is my cursor 1, and then let us say cursor 2 is same. Okay, where is cursor 2? Cursor 1 is here. Okay, so both the diodes are almost having same voltage drop. So that's the understanding. But this is how you can like choose the pick new diode, and you can always work with diode circuitry. Thank you so much, guys.